programs related to finding largest and smallest number in an array. So now we will move to sorting, how to sort the data. Now we can sort any data in two ways, either in ascending order or descending order. Now for sorting we can use bubble sort. Bubble sort is an algorithm to find the largest number among the numbers in an array. So what we do in this, suppose we are taking this example. So we are having we are having an array of 5 elements. These are the elements. Now what we will do, we will compare each pair of adjacent elements one after the another, and in any of the adjacent pairs, if the first element is greater or larger than the second element, then we will swap the elements, and if not, then moves on to the next pair. Like in this 8 and 5. So 8 and 5, 8 is greater than 5, so what we will do, we will swap it. Now after swapping, we will go to the next adjacent pair, 8 and 2. This, then here also first element is bigger as compared to the second, so we will swap it. Similarly, we will go on like this, and at the result of this first iteration, we will get largest number at the last location. Now after first iteration, as we know, all numbers are not sorted, so we will continue this iteration. Now the question is how many iterations we require. So in general it takes n minus 1 iterations, where n is the size of array. So we require n minus 1 iterations in order to sort a given array using bubble sort algorithm, where n is the number of elements. So in normal programming, C level programming, we can see we can use two for loops. This one is for the number of repetitions, and this one is for number of comparisons. If array first element is greater than the second element, then we will swap it. For swapping, we are taking some temporary register. Now same thing we have to do in the assembly language programming. Here what we are doing, we are having n minus 1 comparisons by taking two consecutive data at a time. Now after each comparison, two data can be rearranged in ascending order. We are sorting this array in ascending order. In the ascending order, in the same memory location, that is the smaller number we have to take first, and then the larger number to the next memory location. Now when the above n minus 1 comparisons are performed n minus 1 times, the array will be sorted in ascending order in the same locations. Now this is the flowchart. So we will firstly we will initialize SI register as a source address of array of numbers. Then we will initialize CL register with the array size. Now we will decrement it by 1 to store the number of repetitions. So CL we are taking as a count for number of repetitions. Now similarly we will initialize CH register with array size, and we will decrement it by 1 to store the number of comparisons. So our number of repetitions are n minus 1, and number of comparisons n minus 1. Now we will load first byte of array in AL. Now for sorting in ascending order, we should have smaller number in AL. So we will load first byte of array in AL, compare the content of AL with next byte in the array. If it is less than, then it is fine. If it is less than and equal to, then we will move to this step. Otherwise, if it is greater than the next byte, that means we have to swap. So we have to swap between the two memory locations. To swap between two memory locations, we cannot do it directly with an instruction. So what we have done, we have taken AL as a temporary register. So we have exchanged the data between SI and SI minus 1. We have rearranged the data. So after this, we will decrement the number of comparisons, because we have done one comparison, so we will decrement the number of comparisons. If it is non-zero, then we will again go to comparison part. If it is 0, that means we have done one iteration, so we will move to this next instruction, which will be decrement CL, which is number of repetitions. So we are going to next iteration, so we will decrement CL by 1. Now if this CL is non-zero, then we will again execute these steps. Otherwise we will end the program, and in the same memory location, same input memory locations, data will be sorted in ascending order. So this is the program. For repetition, number of repetitions, we are taking this label, and for comparison, this label. So first of all, initialize memory location for storing array size, then move array size in CL register, decrement CL register to store number of repetitions. Now then initialize the pointer, SI pointer, means now we are getting the array size in next register, ch register, which will be used for number of comparisons. We will decrement it so that to store number of comparisons. Then we will move to next location. Now first location stores the array size, next location stores the first element of the array. So we have moved that first element in AL register. Now we will point to the next data. We will compare it with the AL content. If AL content is less than the next data, that means there is carry, we are taking borrow, so AL content is less than next element, so we will directly go to this ahead label. Otherwise, if AL content is greater than the next element, so we will exchange the data. Now, when we will decrement the count of comparisons, we will again go to this comparison loop. So we will come again do this until we are getting non-zero number of comparisons. Now, if number of comparisons are coming equal to number of comparison is equals to 0, then we will go decrement the count for repetitions. If it is non-zero, that we will go to this level and we will execute these steps. If it comes equals to 0, that means we have performed all the comparisons or the repetitions, means all the iterations. So we will finally stop the program. So this example I've taken, these memory locations are there. First memory location stores number of data, how many data elements are stored in array. Till from this location to this location, we have elements, different elements of the array, and after execution of this program, we will get the sorted data in the same memory locations. Sorted data will be in ascending order. So we will go to our emulator. So I have copied the program here. So now we will go to emulated. So first of all, we will go to memory location where we have to store the input. So DS we have taken 4000, and we will go to 4000 and SI 1200. 1200. So we are storing five elements. So 0, 5, then next 0, 0, A, then next 0, 2, 0, 2, next 0, 9, 0, 9, then next 0, 6, 0, 6, and finally last data 0, 4, 0, 4. So now we'll move to our code segment 0, 1, 0, 0, and we will run the program. Finally, we can check our same locations whether the data is sorted or not. 4000 will be 1200. So we can see this is the array size, and now our data is in ascending order 2, 4, 6, 9, 8. So this way we have sorted our array in ascending order. Now For similarly for the descending, what we have to do, we will do the same process, except now after each comparison the two data can be rearranged in descending order in the same memory location. Now we have to store larger data first and smaller in the next memory locations. Similarly, we have to perform n minus 1 comparisons n minus 1 times. So this is the flowchart. Same steps are there, only if when we compare the content of AL with next byte in array, if it is less than and if it is less than, then we will swap the data. If it is greater than and equal to, then we will go to decrement the number of comparisons. So in same process, like we have done in the sorting data in ascending order, similarly we will do in this also. Just one difference is there here. Instead of jump on carry, there we have used JC. Now jump of no carry. Jump of no carry means AL data is already greater than the next byte. So we will go to directly this label. Now we will decrement the if this condition is not satisfied, then we will exchange the data between memory location and between memory location pointed by SI and SI minus 1. Now on decrementing count comparison, if the number of comparison is non-zero, then we will move to this level, execute these instructions. Otherwise we will decrement the count for repetitions if it is non-zero. So we will again repeat these steps, and if it is zero, then that means we have done all the repetitions, all the comparisons, so we will finally stop the program. Now same example I have taken 5 elements, these 5 elements, and after sorting in descending order, it should come something like this. So now we will go to our emulator. We will make a minor change. Here we will have J and C. J and C. Other things are same. So now we will go to emulate. Firstly, we will make our data segment value as 4000. We will go to this specific memory location. SI we have taken 1200. So here we will make it 1200. So first we will enter array size, which is 05. Then next data 0A, 0A, next 02, 02, next 09, 09, then next 06, 06, and finally 04, 04. Now we have stored our elements. So now we will go back to the code segment 0100 and we will execute our program. So now finally we can see the same memory locations for whether our data is sorted or not. So now we can see there are 5 elements in the array, and these 5 elements are sorted in descending order: 0A, then 09, 06, 04, and the smallest at the end 02. So in this way we can sort our data in array in ascending as well as descending order.